Alright, today we're covering 9.2, which is parabolas. We're going to be able to write equations of parabolas in standard form and graph parabolas. We've graphed parabolas before, but we're used to using a different form, which is ax squared plus bx plus c. We're now looking at them in vertex form, which is the standard form of a parabola. We worked with this a little bit, I think, back in the first trimester. It's been a long time, so we're going to talk about it today. All of your notes are already copied, so I'm just going to go through the examples with you and kind of explain how I got to these answers, what we are doing. So to write in standard form, we need to identify the vertex, axis of symmetry, and direction of opening with the parabola. So we're changing it to our vertex form. I'm starting with what we've been more familiar with, ax squared plus bx plus c. So I factor out -1 first. We don't want anything in front of x squared. We want it by itself. I factor that out just out of x squared and bx. So I've taken out -1. And then from here, what I'm doing is called completing the square. It's a quadratic formula process if you need to review on that. And what we're doing is finding this missing value that goes here. And we're also going to subtract it from the end. We're multiplying it by -1 because we factored that out from the front. So I go through, and what's going to complete my square here is 1, because 1 plus 1 is going to be 2, and 1 times 1 is going to be 1. So 1 is going to go in here and here to complete my square. So then I rewrite it as a binomial squared, x plus 1 squared, and I add that at the end up to 4. So that means my vertex, HK, is -1 and 4. My axis of symmetry is going to be x equals -1, and because we're negative at the front, this parabola will open down. We're going to look at some graphs of parabolas. This is y equals 2x squared. That's pretty standard. My vertex is going to be at my origin, 0, 0, since there's nothing else happening with this equation. And I just plugged in some points to create my parabola. I used 1, -1, 2, -2. When I look at this other graph, it's very similar to our first one. In fact, the first one is a parent graph. So the transformation here is how my vertex changes the graph. My vertex, I used HK to find that vertex. It's 1, -5. So it's the same as the first graph, but shifted right 1 unit and down 5 units. So I went over 1 and down 5 to find my new vertex. And then my points are essentially in the same place from the vertex. So I notice that over here I have a point that's over 1 up 2. So here I have a point that's over 1 up 2. So they're the exact same distance from the vertex, just your vertex starts in a different place. Now we're going to look at graphing some different equations. The first thing we want to do is change our form to our standard vertex form. So I have this equation, x plus y squared equals 4y minus 1. And what I did was change it so that everything is over on the other side. So it's x equals -y squared plus 4y minus 1. And then I don't want that negative in the front again, so I factored it out. I used completing the square again here, and we are adding 4 here and adding 4 here at the end. And then when I rewrite that as a binomial, I'll have y minus 2 squared. -2 times -2 will get 4, and add to make -4. So that's where that number comes from. This information gives me my vertex, HK. It's a little different here because this is an x graph. We notice we started with x equals, so if I look back here, if I have an x equals, then k and h are in opposite positions. And the x graph opens up to the side, you can see in the picture that I've made already. So here's our vertex is at 3, 2. Our axis of symmetry this time is a horizontal line at y equals 2. And because we are negative, we open to the left, so coming this way. So here's my vertex, and I open over here to the left. And I used my parent graph to tell me how it should look, so I graphed x equals -y squared, and I use that to plot points the same distance from the vertex as points from the parent graph's vertex, kind of like we did in that first example of the graph. Basically the same process over here, that I moved everything away over from y to get y by itself, and then I factored out -2 this time, and then I completed my square. Remember that I multiplied that number by -2 to get this -8 here at the end. And then I wrote in standard form by changing to a binomial. That gives me my vertex. My axis of symmetry will be x equals 2. I know because I'm negative at the beginning that we open down. The parent graph for this is y equals -2x squared, so I use that graph. I found them on Desmos to sort of give me a point of reference as to where more points would be, rather than trying to find all these points by hand. The last thing we're going to talk about is writing an equation for a parabola with a vertex at 8, 6 and focus 2, 6. So vertex, the information it's giving us tells us h, which is 8, and k, which is 6. That's just our vertex variables. We're going to figure out first what type of equation we're going to have. Is this going to be an x equals or a y equals? I noticed that my focus and my vertex have the same y, which means I have a horizontal axis of symmetry at y equals 6. So if I go back here, axis of symmetry y equals, this is an x equals equation, so it's one of those sideways parabolas. So I used the focus formula to find a, and I'm going to go back to the front. Right here explains that my focus is h plus 1 for a. So x equals h plus 1 for a. And I know that x in my focus is 2, and I know that h is 8. So I plugged those into my formula. So now I'm going to solve that for a, and I get -1/24. Now here's my form, x equals ay minus k squared plus h. We know k, we know h, and now we know a. So I plug all that information into my formula, and that's my equation. You will have a problem, I think, on your homework that uses directrix. You can use this directrix formula to find a, very similar to what we did for focus. So here's y equals k minus 1 for a, or x equals h minus 1 for a, depending on what your graph is like. Directrix usually says the line, it should be y equals 2 or x equals -4. So you'll know right away what type of parabola you're working with if it's an x or a y.